Are we living in a simulation? The question of whether we are living in a simulation is a profound and speculative one that has intrigued philosophers, scientists, and technologists. The idea was popularized by philosopher Nick Bostrom in his 2003 paper, Are You Living in a Computer Simulation? Here are the key points of the argument and various perspectives on it. Bostrom's simulation argument. Bostrom's argument is structured around three propositions, one of which must be true. 1. The human species is very likely to go extinct before reaching a posthuman stage. 2. Any posthuman civilization is extremely unlikely to run a significant number of simulations of their evolutionary history, or variations thereof. 3. We are almost certainly living in a computer simulation. Bostrom suggests that if future civilizations have the technological capability to create highly detailed simulations of their ancestors, and if they choose to run these simulations in significant numbers, then the probability that we are living in one of these simulations is high. Philosophical perspectives. 1. Skepticism and solipsism. The idea draws on long-standing philosophical skepticism about the nature of reality, reminiscent of Descartes' evil demon and more modern interpretations like the brain in a vat thought experiment. 2. Empirical unfalsifiability. Some argue that the simulation hypothesis is unfalsifiable because any evidence can be interpreted as part of the simulation. 2. This makes it more of a philosophical speculation than a scientific hypothesis. 3. Occam's razor. Critics argue that assuming the existence of a complex simulation infrastructure violates Occam's razor, the principle that suggests preferring simpler explanations. Scientific perspectives. 1. Technological feasibility. While current technology is far from creating a simulation of reality, the exponential growth in computing power, as per Moore's law, suggests that such an achievement might be possible in the future. 2. Physical evidence. Some physicists have speculated whether certain aspects of quantum mechanics or computational limits of the universe might hint at a digital substrate, though this is highly speculative. 3. Testing the hypothesis. Scientists have proposed various ways to test the simulation hypothesis, such as looking for computational limits or anomalies in physical laws, though none have provided conclusive evidence. Cultural impact. The simulation hypothesis has permeated popular culture, notably through movies like The Matrix and various science fiction literature. It serves as a modern myth that explores our relationship with technology and reality. Does this make time travel possible? The possibility of time travel within the framework of a simulated reality introduces interesting and complex considerations. If we are living in a simulation, there are several ways in which time travel could be theoretically conceptualized, though each comes with significant caveats and speculative assumptions. 1. Manipulating the simulation's code. In a simulated universe, the entities running the simulation, often referred to as simulators or programmers, might have the capability to manipulate the code that governs the simulation. This could potentially include altering the timeline, creating save states, or rewinding and fast-forwarding the simulation's timeline. In this context, 1. Rewinding and fast-forwarding. Just as you can rewind a video or reload a saved game, simulators could theoretically rewind the simulation to a previous state or advance it to a future state. 1. This would be a form of time travel within the simulation. 2. Branching timelines. The simulators could create alternate realities or branches by making different decisions at key points in the timeline, allowing for exploration of various historical scenarios. 2. Simulated consciousness transfer. If individual consciousnesses are digital entities within a simulation, the simulators might have the ability to transfer or duplicate these consciousnesses across different time periods within the simulation. This could mean 1. Temporal relocation, moving a consciousness from one point in the simulated timeline to another, effectively allowing the individual to experience different eras. 2. Parallel experiences, duplicating a consciousness to exist simultaneously in multiple time periods, creating parallel experiences of different historical contexts. 3. In-simulation mechanisms. Within the simulation, the programmers could introduce in-world mechanisms that allow for time travel. These mechanisms might manifest as advanced technologies or natural phenomena within the simulated universe. Examples include 1. Time machines, devices within the simulation that allow characters to travel through time, similar to those found in science fiction. 2. Wormholes or portals, natural or artificial structures that permit temporal displacement. Limitations and challenges. However, several significant challenges and limitations arise with these speculative scenarios. 1. Causality and paradoxes. Time travel, even in a simulated environment, could introduce paradoxes and complex causal loops. 1. The simulators would need to manage or resolve these issues to maintain a coherent simulation. 2. Simulation consistency. Altering the timeline or creating alternate branches could demand enormous computational resources and sophisticated management to ensure consistency and stability within the simulation. The philosophical and ethical concerns. If simulators can manipulate time and consciousness within the simulation, this raises ethical questions about the nature of free will, the autonomy of simulated beings, and the purpose of the simulation itself. Key concepts of the multiverse theory. The multiverse theory proposes the existence of multiple, perhaps infinite universes that exist parallel to our own. These universes could vary in numerous ways, including different physical laws, constants, and histories. There are several variations of the multiverse concept. 1. Quantum multiverse, based on the many worlds interpretation, MWI, of quantum mechanics, which suggests that every quantum event spawns a new universe for each possible outcome, leading to a branching tree of parallel universes. 2. Cosmological multiverse, arising from theories in cosmology such as eternal inflation, which propose that different regions of spacetime can undergo separate Big Bang events, creating isolated bubble universes. 3. Mathematical multiverse, proposed by Max Tegmark. This theory suggests that all mathematical structures correspond to their own physical realities, creating a vast ensemble of universes described by different sets of mathematical rules. Similarities to the simulation hypothesis. 1. Alternate realities. Both the multiverse theory and the simulation hypothesis entertain the existence of numerous realities beyond our observable universe. 2. Branching timelines. In the context of simulations, the idea of branching timelines created by simulators aligns with the many worlds interpretation, where each decision creates a new parallel universe. 3. Speculative nature. Both ideas are largely speculative and philosophically intriguing, often challenging our understanding of reality and requiring complex theoretical frameworks. Differences from the simulation hypothesis. Origin and mechanism. 1. Multiverse theory, rooted in theoretical physics and cosmology, proposing natural processes, quantum mechanics, cosmic inflation, as the mechanisms generating multiple universes. 2. Simulation hypothesis originates from philosophical and technological speculation, suggesting that our universe is an artificial construct created by an advanced civilization. Nature of reality. 1. Multiverse theory implies that all parallel universes are equally real, each with its own physical existence and potentially different physical laws. 2. Simulation hypothesis suggests that our perceived reality might be an artificial environment, where the base reality, the universe where the simulation is running, is fundamentally different. Testability. 1. Multiverse theory. Some aspects might be indirectly testable or observable through cosmic background radiation, black hole behavior, or other astrophysical phenomena. 2. Simulation hypothesis. Much harder to test empirically, as any evidence could theoretically be part of the simulation itself. In conclusion, while both the multiverse theory and the simulation hypothesis explore the existence of multiple realities, they do so from different starting points and conceptual frameworks. The multiverse theory arises from physical theories and seeks to explain natural phenomena, whereas the simulation hypothesis is more philosophical and speculative, pondering the nature of reality and our place within it. Both theories challenge our understanding of existence and provide fascinating grounds for thought experiments and further theoretical exploration. Please like, share, and subscribe to our channel to see more videos on thought-provoking subjects.